The last type of related rate problems we're going to look at are the Pythagorean problems, and they're based on Pythagoras' theorem, which is x squared plus y squared equals r squared. In this example, we have Joey perched on a ladder 10 feet tall and leaning against the back of a wall of an apartment building. It starts to slide down, the ladder starts to slide down the ladder at a rate of 4 feet per minute. And Joey's accomplice Lou is standing on the ground 6 feet away from the wall. How fast is the base of the ladder moving when it hits Lou? So we have a right angle, which is right here. And we know the length of the ladder, and I'm going to call that Z, and it's equal to 10 feet. We know the distance from the wall to Lou is 6 feet, so x is 6. So using Pythagoras' theorem, I can initially find out what y is. And we know that x squared plus y squared is z squared. So x is 6. Y squared is what we're looking for, and z is 10 squared, so y squared would be 100 minus 36. Y squared is 64. Y is plus or minus 8, and since we're talking about a distance, y is 8 feet. So I know what that is. Now, we are looking for how fast the ladder is moving when it hits Lou. So we're looking for the change in the x direction. So we're looking for the change in the x direction. And we know that the ladder is sliding down, which would be the change in my y direction. And because it's moving towards the right angle, I'm going to make that negative, and that's 4 feet per minute. The ladder, as it slides, doesn't change its length, so the change in the length of the ladder is going to be 0. Now, we used Pythagoras' theorem once to find our missing side. And then we're going to use Pythagoras' theorem again to take the derivative. But when we do related rates, remember, we're taking the derivative with respect to t. So this derivative would be 2x times dx dt plus 2y dy dt is 2z times dz dt. Now we said dz dt was equal to 0, and 0 times anything is 0. So this whole right side of my equation is going to be 0. So now I'm left with 2x dx dt plus 2y dy dt is equal to 0. And my goal is to find out dx dt. So I'm going to subtract the 2y dy dt to the other side. Divide both sides by 2x. And I can cancel out my 2's. So dx dt is negative y over x times dy dt. Y was 8 feet, so it's negative 8 feet. X was 6 feet. And dy dt was negative 4 feet per minute. So therefore, notice those feet cancel. I'm left with feet per minute. The two negatives become positive. 8 times 4 is 32 over 6, which ends up reducing to 16 over 3 feet per minute. And it would be positive because it's sliding away from the right angle. So we would write our final statement, and we would say the ladder is moving 16 over 3 feet per minute when it hits Lou. And that's how you set up these Pythagorean problems. Now sometimes it might be the y quantity that's not changing, so dy dt would be 0. Sometimes it might be the x quantity that's not changing. Sometimes all three might be changing, and we're going to explore all the different types going through the next few examples. So here we have a plane flying over Lobolis High School. Okay, so here's our ground, here's our school, and it's traveling with a speed of 600 kilometers per hour. It's a pretty fast plane. So dx dt is 600 kilometers per hour. Find the, and he's flying at an altitude of 10 kilometers high. So that means that y is 10 kilometers. Find the rate at which the distance from the plane to the school is changing. So we're looking for this distance, which we'll call dz dt. At the instant, the horizontal distance from the plane to the school is 20 kilometers. So that's when x is equal to 20 kilometers. Now, this is an important statement. It says assume the altitude doesn't change. So right away, my change in y is going to be 0. So first things first, I need to find z. So x squared plus y squared is z squared. 10 squared plus 20 squared is z squared. So 500 is z squared, to square root both sides. I'm just going to take the positive branch because I'm only going to deal with the positive. Okay, and this is 100 times 5, so this is going to be 10 root 5 kilometers is going to be z. So now I know what z is. And now I start with Pythagoras' theorem again. So x squared plus y squared is z squared. So 2x dx dt plus 2y dy dt is 2z dz dt. And this time dy dt is 0, so all of that becomes 0. So now I'm looking for dz dt, so I'm going to divide 2z to the other side. So 2x over 2z times dx dt is going to equal dz dt. The x's cancel. So x was 20 kilometers. Z was 10 root 5 kilometers. And dx dt was 600 kilometers per hour. So our kilometers cancel out. So 600 times 20 divided by 10 square root 5. And this works out to be 536.656 kilometers per hour is dz dt. So you would write your statement that the rate change between the school and the plane is 536.656 kilometers per hour. Okay, let's take a look at this question. Now we have a car approaches an intersection from the east at a speed of 12 meters per second, while a truck approaches from the north at a rate of 15 meters per second. How far is the distance between them decreasing when the car is 30 and the truck is 40 meters north of the intersection? So we have a vehicle coming this way. We have a vehicle coming this way. And we know that the car approaches from the east, but since he's going towards the right angle, we're going to make dx dt negative. So this is negative 12 meters per second. And the guy coming from the north is going to be negative 15 meters per second. And now we do have change in all three directions. So we're looking for the change in the z direction. At the instant, the car is 30 meters east and the other vehicle is 40 kilometers away coming from the north. So again, the first thing I need to do is find z, and using Pythagoras' theorem, x squared plus y squared equals z squared, you will end up getting z being 50 meters, and I'll let you do that on your own, but this is a 3, 4, 5 triangle, just a 30, 40, 50. So now we're going to go back to our Pythagorean theorem. And we're going to take the derivative with respect to time. Whoops. Okay, now I can divide everything by 2 to make my math easier. I'm solving for dz dt. So all I'm going to do is take my left-hand side and divide it by z to get dz dt. So x was 30 meters times dx dt was negative 12 meters per second. Y was 40 meters times negative 15 meters per second all over z, which was 15 meters. So notice all the meters cancel and I'm left with meters per second, and that's what I want for a rate change. So 30 times 12, that's going to be negative 360. 40 times 15. And then we divide that all by 50. And this works out to be negative 19.2 meters per second is equal to dz dt. So that means that the distance the vehicles are approaching, or the rate change between the distance between the two vehicles, is negative because it's decreasing, and it would be 19.2 meters per second. Okay, let's take a look at our last example. And this time we have two cars that leave the intersection at the same time. One's traveling north, the other's traveling east. So now they're going the opposite way. So one car is going this way, one car is going that way. And the car traveling north is traveling at a speed of 90 kilometers per hour. So that's your change in the y direction. And the car traveling east, which we'll call dx dt, is traveling 60 kilometers per hour. And it says, how fast is the distance between them increasing? So we're looking for dz dt 40 minutes after they've left the intersection. Okay, well this question is a little bit different because we don't have a total distance they've traveled, but we know the time they've traveled and the speed. And remember our formula that distance is equal to speed times time. I can figure out the distance. The only thing I have to be careful of, this is in minutes and my rate is in hours, so my time is really 2/3 of an hour. So to figure out my distance x, that's going to be 60 kilometers per hour times 2/3 of an hour. So 120 divided, that's going to be 40 kilometers. And this is 90 kilometers, so to figure out the y, it's going to be 90 times 2/3, and that's going to be 60 kilometers. So now I have enough information to find z. So using Pythagoras' theorem, x squared plus y squared is z squared. So 40 squared plus 60 squared is going to be z squared. So 5200 is z squared. So root 5200 is equal to z, and I'm just going to simplify that. So this is really 100 by 52, which is going to be 10 root 52. And then 52 is 4 times 13, so this is really going to be 20 root 13 is equal to z. Whoops. So z is 20 root 13 kilometers. So now I have to start with Pythagoras' theorem again and take the derivative. So 2x dx dt plus 2y dy dt is 2z dz dt. Again, we can divide everything by 2. And I'm going to divide this left side by z. And then I have my equation isolated for dz dt. So now we plug in our values. So x was 40 kilometers, and dx dt was 60 kilometers per hour. Y was 60 kilometers, I believe, and dy dt was 90 kilometers per hour. And z was 20 root 13 kilometers, and this will equal dz dt. So again, my kilometers cancel out. And if I work this out, 60 times 40 is 2400 plus 5400 is 7800 divided by 20 root 13. And this works out to be 108.166 kilometers per hour is dz dt. So again, you just take a look at your question. Again, it follows the same format. We use Pythagoras' theorem to find the missing side. Then we use Pythagoras' theorem again to take the derivative. And then we isolate for whatever variable we're trying to solve for. In this case was dz dt. And we work it all out. Okay, there is your assignment for Pythagorean questions. And if you have any questions, feel free to send me an email. Good luck.